Welcome everyone to a Kuta worksheet tutorial. Today we are doing simplifying square roots. This is also known as rationalizing radicals, simplifying radicals, however you want to call it. That's what we're going to do today, and I'm going to break it down into two different ways, primarily that we can use in order to simplify these radicals. So if we consider square root of 96, there's a couple different ways to do this. Well, one, you'll recognize if you take the square root of 96, you're going to get something like 9.79. Well, that's not a really nice, neat number. It's not exact, that's rounded. So in math, we have something called simplifying, which means we leave it in exact terms, but we're going to have a smaller radical. In order to do this, we have to look for perfect squares that are within 96. Well, what do I mean by that? Well, we can look here, 96, and we can try to see if there are any perfect square factors. Now, what are perfect squares? One thing you'll have to know is that some of the perfect squares, you should probably commit some of these to memory. For example, 1 squared is 1, 2 squared, 4, 3 squared, 9, 4 squared, 16, 5 squared, 25, 6 squared, 36, and I'll stop there. So if we're looking at bigger numbers, we want to know, are any of these smaller numbers a factor of the bigger number we're looking at? So if we're looking at 96, well, 1 doesn't really count because 1 is a factor of everything. But 4, is 96 a factor of 4? If we do 96 divided by 4, it's 24. So that one works, but we want to try to find the biggest square factor that we can. So 4 works. Is 9, 96 divided by 9. That one does not work. What about 16? 96 divided by 16. Okay, that one works too. So these ones will not work. 36 is too big. Okay, but we know that 16 will work. So what I'm trying to say is we can rewrite this problem, square root of, and instead of saying 96, we can say this is the square root of 16 times 6. And you're going to see why I did that in just a second. Now, 16 times 6 equals 96. So we can rewrite this again as square root of 16 times the square root of 6. Why would I do that? Well, because I know what the square root of 16 is. I know the square root of 16 is a perfect square, and I know that it's equal to 4. Now, square root of 6 does not have any other factors, so we have to leave it as the square root of 6. So this 4 times radical 6, 4 times the square root of 6, is the same thing as the square root of 96. You'll get the same answer. It'll be the same answer as the decimal we first got, but now this looks a lot better than when we first wrote that rounded decimal, okay? So that's what it means to simplify, is to get it like this. Now, there's another way to do this, and this makes it a little bit easier so you don't have to trial and error with, let me circle these, so you don't have to do trial and error with the square roots. Okay, this way will work every time, and it's using a factor tree. So let me go ahead and get a different color out. Okay, I'm gonna move this over. Need a little bit of room. Okay, use a factor tree. So just a reminder of factor tree. You're trying to find numbers that are factors of 96 and then split up those numbers into additional factors as well. Now, what I always like to do is I like to put the prime numbers on the left. So that gives me a little bit of organization. So for example, 96 divided by 2. I always divide by 2 if I can. I think that makes it easier. And I get 48. I'm going to divide that by 2. I get 24. I can divide that by 2. It's even. I get 12. Boy, lots of 2's here. 2, 6. And then 2, 3. Now, what do I do with this? Well, what I could do is I could look for perfect squares here. But essentially what we're going to do is we're look for pairs. Pairs of numbers. Now, why do I look for pairs? Well, what we can do here is we can rewrite square root of 96 as 2 times 2 times 2 times 2 times 2 times 3. 2 times 2 times 2 times 2 times 2 times 3 equals 96. Okay, so I rewrote it. Now, what I'm going to do is I'm going to group it like I have in the factorization. Notice how I keep these guys separate, 2 times 3, because they don't have a pair. They don't have a partner. Now, square root of 2 times 2 is 4. Square root of 2 times 2 is 4. Or excuse me, square root of 4. And then we have square root of 2 times 3 is 6. Now, why did I do that? Because we recognize that the square root of 4 is 2. The square root of 4 is 2. So I can rewrite this again as 2 times my radical 6. And I can't simplify this any further because it's not a perfect square. So then this turns into 4 radical 6, and that's what we got in the first place. Okay, so there's two methods here. We have looking for perfect squares. That's the first method. And then we have the factor tree method. Factor tree method always works, and sometimes it's a little bit longer, but it always works. That's a good method to use. I recommend both. Okay, so a number like 216. Same deal. This time I'm just gonna pick one of them. I'm just gonna pick the factor tree. So I'm gonna do 2, 108. 2, what do I get? 54. 2, 27, 3, 9, 3, 3. So it's not too bad. Now what I'm doing here is I'm looking for pairs of numbers. Remember, anytime we have a pair, I have a perfect square. Anytime I have a number left over by itself, it gets boxed because it's going to stay in the radical. The rule of thumb is if you have a pair of numbers, one of those numbers is going to leave the radical. One of those pairs of numbers. So we have a 2 and 3 here that are going to leave. 2, and you multiply anything that leaves. 2 times 3, and then times what's left inside the radical, the things that are boxed. 2 times 3, those are left alone. Okay. Another rule of thumb is, this is how I like to think of it. I like to think of the radical as a house. Okay, so this is the house, and in order to leave the house, you have to have a date. So the 2's had a date. The 3's had a date, so they get to leave the house. But the 2 has to stay home, and the 3 has to stay home because it doesn't have a date. It doesn't have a buddy, okay? So this gets reduced to 6, 2 times 3 is 6, times radical 6, and that's our final answer, okay? If you were to multiply this out, you'd get square root of 216. So we have some 2 tough ones out of the way already. We can do one like square root of 45. Okay, we're going to do this a little bit more quickly now. We get 5 times 9, and we get 3 times 3. 3 is the only pair there. Okay, so 3 is a pair. We're going to take out the 3. 3 leaves the house, and that is square root of 5. Just as a reminder, it's like, okay, how do I do that? This could be rewritten as square root of 3 times the square root of 5. That's the same thing as 45. That's the square root of 9 times the square root of 5. The square root of 9 is 3, 3 radical 5, and that's another way to look at it, okay? Square root of 12, 2, 6, 2, 3. There's a pair of 2's that leaves. Okay, if you don't have a highlighter, I generally just circle them. So I have 2, a 2 leaves the house, 3 has to stay home, 2 radical 3. What if there's something already in front? Well, we already knew that radical 96 is the same thing as 4 radical 6. So let me rewrite that. We had radical 96. That could be rewritten as 4 radical 6. But we still have this 10 out in front. So we have to multiply the 10. So we have 40 times radical 6, and that's all there is to that one, okay? Anytime you have a number already out in front, you just multiply it when it's done. All right. This one, number 17, we have 2 times 30, square root of 36 is just 6. So this one ends up being perfect, 12. And the rest of these, I guess, are just going to be tough factorizations. This one I would simplify into perfect squares. Some of them lend their hands to just looking for perfect squares. And the reason why is because I know 900 is the same thing as 9 times 100, both of which are perfect squares. So I'm going to say square root of 9 times square root of 100 times 3. And that's the equivalent of this. So we have 3 times 10. So we have 3 times 3 is 9 times 10 is 90. So we get 90 for our final answer there. Let's do a hard one like this 2535. Anytime it ends at a 5, don't forget about keep the 7 at the end. Okay, so we know we're gonna have a 7. Don't forget about him. So we have, I'm gonna use a calculator to help. 2535 divided by 5. What does that equal? 507. Yuck. I know it's divisible by 3 because the 5 and the 7 and the 0 add up. The digits add up to 12, which is divisible by 3. So I'm going to divide that by 3, which is also a prime number. Again, I want to keep my prime numbers on the left. So I put my prime number on the left, 3, and it's 169, which is that divisible? I think it's divisible by 13. It is. Okay, it's divisible by 13, and it's 13. Now, if you get something like this where you have 169 and you get 13, 13, or let's say it's even like 81 and you get 9 and 9, you don't even have to worry about factoring it further. What you can do is you can be right here and be like, okay, look, I know 169 is a perfect square. I'm just going to stop it right there because I can rewrite this. Okay, so look, we didn't have a pair for 5. He stays home. 3 stays home. But 169, let me show you what this is all about. We can write this as 169, okay, times radical 5 times radical 3. 7 times 169 is 13 times 15, radical 15. So now I do 7 times 13, and I get 91. So 91 radical 15 would be my answer here. Okay, now if you didn't like that, you're like, okay, too much information, just tell me how you did it in the first place. Okay, we have a pair of numbers. So we had the 7 originally times the 13 that came out. Okay, let me highlight this just so you can see it a little bit better. The 13 that came out, and then we had the 5 and the 3 that stay home. So then we have 7 times 13, 91. Radical 15, we got the same thing, okay? Hope you guys found this video helpful. If you need any more help with radicals, let me know. If you have any other subjects you want me to cover, leave a comment. Thank you for watching this video. I look forward to seeing you next time.